So, dear friends, once again welcome. Let us discuss the simply supported beam with a point load at midpoint. So, our objective here is to determine support reactions. Support reactions. Okay. So, like a beam, this is the beam. One end it is hinged, other end it is roller support is there. Okay, and you might be knowing if you remove this roller, there are three rollers you can see here, so it becomes hinge. But we have to take care of whether our structure is statically determinate or not. So that's why here for the three equations, three unknowns are there. Okay, and suppose this W load is acting at the mid of length L beam. So from here to here it is L by 2. Okay, so free body diagram we have to draw. So what you have to do here, you have to remove the supports. Okay, this is what FBD, free body diagram. So supports at end A and B we have removed. Okay, and this is VA. Here due to the roller it is RB, and the horizontal HA is equal to 0. Okay, now so we have only two unknowns, this one and this one, means VA and RB. So satisfying the equilibrium conditions, so summation of F y is equal to 0, then VA upward direction acting upward direction, that's why positive, RB acting upward direction, that's why positive, and A is equal to 0. So it is our equation number 1. And suppose we are taking moment about any point, either A or B you can take. So the length is here, and one more thing here I forgot actually, sorry. For the W we have to consider W at L by 2 distance. Okay, so here minus W is there, so it become, so okay, so what happened, VA plus RB is equal to W. Actually this is our first equation. Now we have to satisfy the moment equation. So moment about summation of moment about O, about, sorry, A. Okay, so moment about A, so W will try to rotate the beam, and this clockwise we are taking negative, so W will try to rotate the beam clockwise, that's why negative, and it's a perpendicular distance L by 2 we have multiplied. And what about the RB, this one, RB will try to rotate the beam the anti-clockwise, RB, and what is the distance, so L is equal to 0 here. So this is our equation number 2. Okay, so what we get from here, so we get RB L is equal to WL by 2. So it becomes the RB, this RB is equal to W by 2. And since the beam is symmetric beam, so that's why VA is equal to RB is equal to W by 2. Or if from equation or from equation 1 also we can solve. Okay, what is our purpose? To know RB we know, then our purpose is to know VA. So VA is equal to W minus RB, and if you put the value of RB here, so it becomes W minus W by 2, so it is 0 by 2. So what are our findings? So HA is equal to 0, VA is equal to W by 2, and it is equal to RB. So this is our answer. So don't forget, at the last write all the answers together. Okay, thank you. And suppose the simply supported beam, this is the beam A, B, here the length is L, and support reactions now we know VA, and this RB, and the load is acting at somewhere, not at the mid. The load is acting not at the mid. So what will be VA and RB will be what? So it is very easy. Suppose it is a distance from A, it is A distance, and from here to here, from point load to B, it is B distance. Okay, so what we have to do now? Simply nothing. We have to satisfy the equilibrium conditions to know, and this is what the simply supported beam. Simply supported beam with point load okay, and a point load not at the mid. Okay, so now we are going to satisfy the equilibrium condition. So summation of F y is equal to 0, and here what we get, VA and R plus RB minus W. Okay, so VA plus RB is equal to W. So this is same like a previous question when the load was working at the mid. So this equation is same. So let us give it the equation number 3. Okay, and moment, next we have to satisfy moment about suppose B we are taking here. Okay, then moment about B, then W will try to rotate, and the direction we have to show, this is minus, the clockwise direction we have taken minus, so W will try to, this W will try to rotate the beam about B. So how? Means the anti-clockwise, that's why W, and the distance we have to multiply, it is B. And what about VA? VA will try to rotate the beam clockwise, that's why minus, and multiplied by, it is L, so is equal to 0, and it is fourth equation. So what we get, what is unknown here? So our unknown is this one. Okay, so VA multiplied by L is equal to WB, and VA is equal to WB divided by L. So similarly we can get VA, this is VA. So what by putting this in equation 3, what is VA? RB is equal to W. So RB is equal to what? W minus VA. So W minus, and what is the value of VA? This is means the expression WB divided by L, and is equal to what? It is WL minus WB divided by L. Okay, and here W is common, so it is L minus B divided by L. So it is equal to L minus B, means this L minus B is equal to what? It is A. So RB we get WA divided by L. So what is our findings? Here answer. So VA is equal to what? So VA is equal to WB divided by L. And what about RB? And it is WA divided by L. So this is our answer. Okay, thank you.